you very much. So what I want to talk to you about tonight is our work in environmental sustainability. Microsoft's mission statement: empower every person and every organization on the planet to achieve more. That's our new mission statement, replacing what was in the past a PC on every desk. You know, PC on every desk, we feel that's really been accomplished. Now we walk around with PCs, you know, just probably several of them in our bag these days. But, you know, our mission now as essentially a cloud provider for our customers and our partners is to empower every person and every organization on the planet to achieve more. Now, what's that mean, though, in a resource-constrained world? We really want our customers, our partners to thrive. So we have a focus, really 3 pillars. First is sustainable operations, and I'll talk a little bit more about that, which is what we're doing in the area of innovation with our data centers. But we also focus on our technology, how we're leveraging artificial intelligence, what we call AI for Earth, which is focused on animal and plant ecosystems, leveraging AI to improve the planet. And finally, our public outreach, so global sustainable leadership, community engagement, policy, and public relations. So those 3 pillars really make up the work we're doing in this area. One thing we're very proud of is we have achieved 100% carbon neutral footprint. So by purchasing and applying carbon credits and some of the other work that you'll see that we're doing with our data centers, this is something we're looking to continue and maintain. So the reason that this work with data centers is so important is we have 54 regions around the world that make up our Azure platform. In each of those regions, there are multiple data centers. So we are taking up a fair amount of real estate with those data centers. Each of those data centers is multiple football fields in size. And when we bring capacity into those data centers, it's done a container at a time, where each container is filled with thousands of servers and storage capability. So we bring those containers online and we take them offline a container at a time. So there's a significant use of power, certainly the cooling of those systems. This has an impact on the environment. But you've seen that we've made a focus to make sure these data centers have a zero carbon footprint. But we believe there's more that we can do. And that's what Project Native was all about. So the problem was to construct a data center in a fast-paced way. We created a data center, let's say, in 30 days. And then provide some options on how those could be deployed. Where could we put them? And create a self-contained, quickly deployable data center that can be essentially produced instead of constructed. So here you see a photograph of one of these data centers being built. So you see there's actually the actual server infrastructure itself being placed into a circular container there. And we then can take that container, and whether we take it by truck or train or barge or boat, bring it to a location and submerge it under the water. Use the water to cool the data center and not take up useful real estate. So you can actually see this data center being submerged off of Scotland here. And some of the challenges there, though, is that you really need sort of a lights-out operation, right? We don't have divers going down there and hot-swapping hard drives, all right? That's not happening. So you have to deal with the fact that this thing really, there's no people involved. You have to deal with oxidation and moisture, dust, gaseous contamination, the temperature issue. So a lot of innovation going on to create this truly lights-out operation. It's consistently cool because of being surrounded by this cold water. There's no oxygen. It's a low moisture nitrogen atmosphere inside the container. And so there's no risk from external gaseous or particle contaminants. We're also leveraging our AI for Earth to study the ecosystem impact of these submerged data centers. So imagine, we're in essentially the testing phase of this right now for the next 5 years. But imagine a time where we're able to take data center capacity, bring it anywhere in the world to populations that aren't near the physical data centers and say, look, we can just submerge data centers right offshore and we can provide you compute and storage. Because guess what? The speed of light is still the speed of light. So being close to that data center matters. So we're using AI for Earth in order to study the fish ecosystem around the container and building up a lot of knowledge about the kind of fish that are there. Is that changing over time? Are we affecting, those are all fish, by the way, as you can tell. But that's an example of leveraging the object recognition cognitive service that's part of Azure. So this environment's completely IoT enabled. We're bringing the data into Azure. We're doing predictive analytics and leveraging cognitive services to study the impact on the environment. So again, our mission: empower every person and every organization on the planet to achieve more and to thrive in a resource-constrained world. Thank you very much. Now is the time where I will take some questions. Any questions? Yes, sir.
It's submerged. How is that interacting with the public internet? If that data center is submerged?
Great question. The data center is submerged. How is it connected to the internet? In one of the pictures, there was this big cable that was coming in from the side. Let me step back here. Back to one of the, you can see it right there actually. Now, what is that? Well, it turns out Microsoft owns all the dark fiber that connects all of our data centers globally. We laid that cable under the ocean. We own it, we maintain it. It's one of the things that makes Azure as secure as it is, more secure than we believe other clouds. I'll just say it that way. When you're in Azure, you're in a secure environment all up, and Microsoft is maintaining everything from the physical environment, all the way to the cable as it stretches across the ocean. So we're able to take these data centers, bring them to where cable is, and just drop it down and hook it in. Great question. Any other questions? Yes, sir.
How are you studying the heat impact around the fish population?
So the question is, how are we studying the heat impact? So the entire data center container is infused with IoT sensors, both inside, externally, and as you can see, there's also cameras outside. So we're leveraging the telemetry data coming from the sensors as well as the data from the cameras to bring that into Azure. If I go to the architecture for that, combination of Azure Media Services for the video, and the telemetry coming in through our IoT hub, bring that over into our machine learning environment where we're doing a combination of object recognition, obviously object recognition on the fish, but also analyzing that raw telemetry and studying it over time. So one of the things we're doing here in a classic startup mode is minimal viable, right? This is a minimal viable submerged data center. So we didn't go out and produce 10,000 of these and drop them in the ocean without knowing what the impact would be. This is one data center off the coast of Scotland, and we're going to study it for 5 years. And if we're going to see what the impact is on the environment, on the ecosystem, on the fish, and if we determine that the steps that were taken protect that ecosystem, then I'd say we have a winner, right? We'll move forward. If we find any issue, we certainly will back it out.
How do you see this scale to larger systems?
The question is, how do we see this scaling to larger systems? I think we see it as addition. So within even just that one container are thousands of servers and storage capacity. Imagine now the ability to have multiple of those containers brought into underwater in some location. You're scaling your capacity that way. It's the way we scale on land as well, right? When we have a data center, we don't have just a building and you walk in there, it's just one row of servers that goes on for half a mile. The servers are actually in truck containers. And if you can imagine, like the back of a tractor trailer, right? But that's filled with server capacity. We bring that into a physical data center on land the same way. We drop it in place, we plug in electricity, Ethernet, cooling, and we bring it online. And then we stack those, could be six high, right? And so that's how we're building our capacity in Azure globally. It's the same approach here.
So you have building on shore, with a big switch and power distribution.
Yeah, in this case, what we're studying is that this is hooked into a power grid supplied by Scotland, and it is also following a very green approach to the production of that energy as well. Yeah. But this is all going into the study, right? How can we do this and maintain that carbon neutral footprint and no impact on the environment? It's very challenging, but yeah, it's worthwhile.
Are they at all playing with tidal as a source of power? Is that played into it all?
That's it. So the question is, are they playing with tidal? So actually the power of the water itself? I don't know, but they must. It's one of those things I couldn't discount it. It sounds like it would be a brilliant idea. All right, all good. Thank you very much. Appreciate your time.